Here we go, live, calculus, Pendleton, Emmegren Hall. Pizza and pie if you happen to be live. If you're in the future, I'm so sorry. Track me down in Pendleton soon. I owe you a slice of pizza. Question here about Newton's method for this equation. We have these two functions. I'm guessing the black one is the arctangent and the blue one is the logarithm. And we want their intersection. Newton's method does not find intersections directly. What we have to do is get one side equal to 0 so we can find a function on the other side. So first step on this sucker is to solve for x. The direction you choose doesn't matter too much. I'm going to take the logarithm over. So this is going to give me the arctan of x. I'm going to write that as 1/5, if that's okay, minus 1.2 natural log of x equals 0. So once I have 0 on the other side, that means I'm looking for a root of a function, and this right here must be my function of x.
What's the derivative?
Derivative arctangent is 1 over 1 plus the square of the inside. So f prime of x, the 1/5 is a constant multiple, it just hangs out. So I have 1/5 times 1 over 1 plus x squared. Minus 1 2/10 times the derivative of natural log, which is 1 over x. And although we probably could clean this up a little bit, it's probably not worth our time. With Newton's method, we're just going to plug and go. So Newton's method, we get this recursive function I'm going to call n of x, where you start off with some x value and then you subtract the ratio of the function to its derivative. So the function is 1/5 arctan of x minus 1.2 natural log of x divided by its derivative, 1/5, 1 over 1 plus x squared minus 1.2 over x. And then we just pick some calculating device and plug in and see what happens. So I'm going to do a spreadsheet first because I didn't get to last time.
Will spreadsheets do arctangents?
It's ATAN.
Yeah, ATAN in a spreadsheet, yeah. So we need a starting point. So how about 4.3-ish?
Sounds good.
Yeah, so I'm going to type in a spreadsheet, I type my starting point first, and then underneath I do equals, and then every time I need an x, I just click above. So x minus 1/5 times the ATAN of x minus 1.2 times, and I can't remember what they have for log. Oh, they have an ln. Nice. So they have an ln of x. And I forgot to wrap that whole thing in parentheses, starting with the 1/5. And then I want to divide parentheses for the division. And then here I have 1/5 times 1 over parentheses 1 plus x squared, close that denominator, subtract 1.2 over the ln of x. Close the ln.
Shouldn't that just be 1.2 over x?
Oh no, it's just over x, not the ln. Oof, thank you, Sarah. You saved my butt. Okay, and that closes my parentheses. Okay, so if I close my parentheses correct, then I get negative 1.2. Crap, I screwed something up. Should not be negative. Okay, where did I go wrong here?
That would be like all less than
1/5 arctangent of x, right? Minus 1.2 natural log of x. All right. So denominator, 1/5, 1 over 1 plus x squared minus 1.2 over x.
Yeah, because we messed something up.
Huh.
I got undefined.
It's because we messed something up.
Okay, I got an error somewhere. Okay, let's
That's what I'm
see.
saying. Like, okay.
Did I get the function right? Yup. Arctan 1/5 minus, okay. 1/5, 1 over x squared, that looks right. Huh, okay, well, interesting.
Oh, I think there is an answer.
Yeah, I think this one's broke because every single problem I get is undefined. And I did like,
Well, let me run an iteration of it and see what happens. Maybe it'll settle down. Ooh, because you can't take the natural. Oh, my initial guess might be the problem. Okay.
What do I think?
It looks like 4 point
I had the
something.
same problem.
I put 4.5 and I got the same thing as you guys.
Here, I'll put in 3.
Let me
just
try
so, like,
4.
be
So
But
safe.
it's like it's undefined until I got like.
Yeah.
Yeah, no, if you put in 4, it does the same thing.
Until I get down to 2.
Like 2 or something.
Yeah. So I just
Really?
did.
And I still got off.
But that's not the right.
Right.
Okay. All right, let's go to Desmos.
No,
So
I'm on
with
Desmos.
I'm doing it on
Desmos,
Desmos.
I have
then.
1/5 of the arctan. Is that what Desmos takes? Yep.
Yeah.
Of x
Minus 1.2.
versus, oh yeah, let's do the minus 1.2 times the natural log. Oh, I think I might know what's wrong. Of x. Close parentheses. This one says it happens around 1.5. Oh, there's something wrong with this picture then.
it's
Huh.
broke.
Maybe it's upside down.
Maybe it's negative, everything.
No. Yeah, there's something wrong with the picture. Okay,
You should just
I
delete
will.
that question to give
Yeah.
us full credit for it.
I will make a note that that picture's wrong. All right, so let's see. According to Desmos, we should start closer to 1. So if I go back to my spreadsheet here and I plug in 1, then it settles down pretty quick to 1.53448, which Desmos says looks good.
I got a number that was closer to 1 and I got
I put a
a
negative.
value, but I plugged it in.
Do you have the same constants as me? Oh, and it didn't like it? Oh, so the whole problem might be messed up? Okay, so let me 5 decimal places. According to the spreadsheet, 1.15345. 15345. 1.15345. Submit. Damn. Okay. There's a problem with this question. All right. So let's report a problem to the editor who wrote it. A Yanushka. I think I'm going to explore it before I write to A Yanushka. All right. I'll review their code. So I'll just give everybody credit for it for now. Because I assume you all tried something reasonable. Huh, bummer. Okay. I'll get back to you once I find the problem with their code and then ask them to fix it. All right, what else should we do?
Antiderivatives.
Antiderivatives. Good call.
Antiderivatives and integrals, same thing.
Yes and no. You use antiderivatives to help solve integral problems. So they're a one technique to solve integrals.
As for an antiderivative, do you just go one place up or how many?
So let's see, which one should we do? So here it says plus c, that one's, let's do this one, why not? All right, consider the function f of x, enter the antiderivative of f of x. So basically they're telling this is the derivative of some function, what was the function? So let me copy that.
They go up.
What's that?
How many places? Just one?
What do you mean places?
Like, how many times do we need to do it?
Oh, just once.
Oh, okay.
Yeah, Siler's question was a little just like, not off the wall, but a step harder. Yeah, here we just need to find one antiderivative. So the bottom line is the 8's a constant, so I'm just going to hold on to that 8, okay? And then with a derivative, we drop a power by 1. With an antiderivative, it's got to go up by 1. So that means this should be an x to the 11th power. Now, if that was true, when I took the derivative, there should have been 11 out here, but it's missing. Hello? It is. Hi.
Did anyone see number 4?
Dude, I haven't even looked at this homework yet.
Me either.
Oh, because it's not due till Saturday. I have.
Finishing up.
It's just ln. It's 10 ln. Okay, thank you.
X.
Whose method is just super? This one's 9x7 over.
Domino's apologizes for the delay. They're on their way. Okay, so we got a 1/11th here then to adjust because we're missing that.
Wait, new question.
We
Yeah.
multiply
Why
them.
is it 1/11? Why is that 1/11 to adjust?
Isn't it just
Because
one
then when
time?
you take the derivative of that and the 11 gets multiplied, it'll cancel out that 1/11th and the 8 will stay.
Okay,
That make sense?
yes.
Wait, so
Okay.
did you?
Thank you.
So 9, and then I'm gonna leave a little space. This is gonna be a 7th power. Since there's no 7 out here, I have to adjust with a 1/7. Minus 8 times x to the 3rd, but there's no 3 here, so I have to adjust with a 1/3.
Wait, I have a quick question.
Hang on. Minus 8, that's an x to the 0 essentially, so this becomes x to the 1. So then cleaning it up, I would say this is 8/11ths x to the 11 plus 9/7ths x to the 7th minus 8/3 x to the 3rd minus 8x. Plus c, now they already put the plus c on the outside, so I wouldn't add that here. Yeah, so that'd be the answer I enter there. That answer your question, Ruby?
Yeah.
Okay. All right, let's try another one. What looks like fun here? Kyler, number 3?
Yeah.
Okay. Oh, beautiful. I love number 3. All right. So this is the derivative of function. We want to find what is the function, and they're going to also tell us that f of 1 was 0. So that'll help us find the missing constant. So copy. New page. You guys are so good about waiting for your dessert till after your pizza. Amazed. All right. So this is the derivative right here of that capital F. So we want to figure out what F is. Now, before I do that, I'm going to rewrite these as negative exponents. So this would be 3 times x to the negative 3rd minus 2 times x to the negative 5th. And remember, a derivative, we reduce the power by 1. So the antiderivative, we increase by 1. So this is going to be 3 times, if I increase negative 3 by 1, I get x to the negative 2. There should have been a multiple of negative 2 out here. Since it's not there, I'm going to throw in a multiple of negative 2, or you could of 1/2, or just divide by negative 2. Okay. Minus 2 times x to the negative 4, and then we'll throw a negative 4 underneath there. Now there is technically a plus c chilling out there. We'll deal with that in a sec. Cleaning this up first, I would call it negative 3/2 x to the negative 2 plus 1/2 x to the negative 4 plus c. And to deal with the constant, they told me that, hey, the original function, if you plugged in 1, you got 0. So let's plug in 1 and see what happens. So using the clue that f of 1 is 0, then we get 0 equals negative 3/2. 1 to the negative 2 is 1, plus 1/2. 1 to the negative 4 is 1. So I get a plus 1/2. So that gives me negative 1.
The
C is
constant
negative
must have been.
So the constant must be negative 1. Yeah, that's what we know now. Oh, wait, no, shit, I
No,
didn't
no,
do
it
that
should be
right.
positive
Control
one.
Z. Yeah, I forgot to write the plus C here. Plus C, this gives me negative 1 plus C.
So the constant would have been.
So the
1.
constant, solving for C, the constant's 1. So C equals 1.
No.
Yeah, sorry about that. So C is 1. And so that's what we would enter into the system. This with a C equal to 1.
How did you get it? You plugged.
I plugged in the 1 here and here, and 1 to the negative 2 is just 1, so I get negative 3/2. 1 to the negative 4th is 1, so I just get a 1/2 there.
And then for the C, you basically.
And C is just C at the moment, so now I have 0 equals negative 1 plus C. To solve for E, we add that 1 to the other side. So that tells us C must be 1.
And on that side, you got a -1 because you brought the 1 over.
I got a negative 1 here because negative 3/2 plus 1/2 is negative 2/2,
Yeah.
which is negative 1. So now I know that 0 is equal to -1 plus c. So to solve for c, we add the 1 to the other side. That tells me c equals 1. So then I would enter into the system this stuff plus a 1 here. I think it's fun.
No, can we do number 9?
Perhaps. We can certainly try. Excellent. Okay. So, screenshot.
Number 9 was it?
Yeah, this is number 9.
The whole thing was there.
There's the arch one.
What is it?
Is that just the arch one?
Okay, could be.
Yeah, it'd be 15 numbers.
So this is number 9. So there's two perspectives on this. Come on, pen. There we go. If I pull out that -4, and I have -4 times 1 over 1 minus x squared inside the square root, and this right there is the derivative of the arcsine.
Okay.
Yeah. So that's one possibility. So usually we call, we say capital F prime is equal to little f. So capital F, the original function, could be -4 times the arc cosine of x plus some constant. But could be. Check this out.
Probably.
I could have done this a little bit different. I could have said that capital F prime was 4 times -1 over square root of 1 minus x squared. Does anybody know what the difference is if I put a -1 up there?
It's the arcsine.
Cosine. It's the arc cosine.
Well, but you wrote cosine for the other one at the beginning.
Oh shit, I wrote that
So
wrong.
that's what DD.
Oops. This should have been the arc sine up here. I was thinking ahead apparently. So one answer is -4 arc sine of x. Another answer based on this over here is that f of x could be +4 times the arc cosine
So how do we decide
Cosine.
which one it is?
of x plus c. Well, here's the deal. Based on the, was it the intermediate, the mean value theorem, one of the consequences of that was that if two functions have the same derivative, that means those functions must differ by a constant.
Okay.
There's that so those c's aren't going to be the same, is what is the consequence of what's going to happen here. Yeah. So there are two different antiderivatives here, and it turns out if you graph these two, you'll see that one's just shifted up or down compared to the other, if we were to graph them. Right, so let's just take a look just to see.
That doesn't really answer my question.
Wait,
Which one is the right answer? They're both the right answer.
So we could have.
You
entered
pick
either
one of them.
those.
Yeah.
It'll say.
Dominoes! Woo! Yeah. So I'm going to turn this, let's get rid of that. Good, how are you? Let's see, you totally gonna steal your spot. Well.
What kind of pizza did you get us, Gary?
We got pepperoni and we got veggie. Oh, yes, there you go, sir. Thanks a lot. All right, so this one is pepperoni, this one is veggie. Dig in. While you dig in, I'm gonna type some stuff into Desmos. Oh, I should have guessed I could have put the plates. You guys can get plates. Good to move around and do math. So -4
Here, I got you a
times,
plate.
thank you, the arc sine. I'm good for now, thanks.
Favoring the one
Of x versus 4 times the arc cosine of x.
Yeah, it's like, this is a bro when you have. I was like,
There's also root
I just
beer.
laughed at it. Yeah.
There's also root beer.
Oh, Yes, of course.
This one piece.
Yeah.
Also, I bought it.
Yeah, I was like, is this one?
Oh, yeah.
Here. I'll show you. Oh, really? Oh, I was just gonna do it. I still gonna do it the wrong way.
Use your muscles.
Oh, it's just taking it. Make you.
Thank you. Who wants root beer?
Are you struggling? Anybody else? Anybody else? Guitar? Do you want to?
I'm not dying.
You're on a diet? Seriously, that was what you said?
You're gonna be like, I
Anybody
don't know
else?
where that
I meant to be the
I got this with a bubble right here.
You know.
Actually, I like these. I like this. Pieces of bubbles.
So I saved my second cup of coffee for today, just for now, because I love coffee and pie.
That's weird.
You only eat so much coffee or drink so much coffee.
I can't handle too much caffeine because I'm already like jumping around like a rabbit. Yeah, so I do like coffee. You know what's funny is I didn't start drinking coffee till I was 30.
Oh, wow.
Whoa.
Whoa. I think was when I tried it before. I was like, oh, that's disgusting. But then a friend of mine said, well, try it with half and half and have some pie with it. It's like, oh my God, this is an amazing combination. And I was so amazed by that I ended up marrying that person after.
Oh, really?
Yeah.
Really?
Yeah.
What did you get to college about coffee?
What's that?
Have you met him? Do you think he needed coffee to get through college?
Oh,
Imagine what it was like 20 years ago.
I've always had a ton of energy and didn't need a lot of sleep, so which was the perfect thing for a math person, you know, and an inquisitive mind, a person that doesn't mind getting things wrong and trying again. So I graphed the negative 4 arc cosine and negative 4 arcsine versus 4 arc cosine, and what does it look like? The difference between the two graphs is
One's higher.
one's just shifted up compared to the other. Yeah, so they just differ by a constant. And this happens a lot when you're doing antiderivatives with a complicated function. One person does it one way and gets an answer, another person does it a different way. They don't look the same, and there's 2 ways to tell. Now, graphing is just kind of kind of looks like they're the same shape, but it's not a definite, right? The only way to know for sure is you just set them equal to each other. And if you solve, you should eventually be able to whittle it down to a single number.
Right.
So it's just the way it is. Because when, I don't know what else to say about it for now, but you'll learn more about this in Calc 2. This is a big part of Calc 2.
No thanks.
All right. So let's see if it likes my 4 times the arc cosine of x. And I think it probably wants a plus c.
No, it already has a plus C in there.
It already has a plus c there? Oh, yeah. Oh, it puts it in there for me. Okay. For the arc cosine, it's positive.
Oh, yeah. Yes.
Liked it. And then I could try it again with the arc sine, but make it negative. And it should take that too.
So maybe because -4 is already
Yeah,
negative,
it likes it.
zero.
It's, again, the reason behind this new page is that if you take the derivative with respect to x of the arc sine, you get 1, positive 1 over the square root of 1 minus x squared. But if you do the same thing with the arc cosine, you get a negative in the top, and that's it. So the arc cosine pretty much eats the negative when you go in reverse. Oops. So back here, when I separated out the -4, since that was positive, it's natural that I put the arc sine here. But if I leave the negative in the top, then the arc cosine should be the answer. But there's no more negative out front because the arc cosine is part of its being. Woo, fun. Okay, so Let's take a look at a problem from one of the sample tests. How about that? Let's see, where did I post that?
Are we
There's
gonna replace the most random for tests for final?
oh, I forgot to consider that proposal.
So you know the material, you know the first time.
Yes, I will do that. I'll send out an email to the whole class today saying, if your final exam is better than either of your tests, then we can replace your lowest test score with the final exam score percentage. Yeah. If your final is worse, I'm not going to mess with anything.
So
Your final is just
you're
worse.
screwed.
Yeah.
Lovely.
All right. So let's see. Let's take a look at the practice. Okay. Beginning, no big deal. You guys got that stuff there. I'm going to go find something much more exciting, like, ooh, the highway patrol one. That's a good one. The box and the poster.
Highway patrol.
Highway patrol? Okay, highway patrol it is. Let's blow it up again. This highway patrol one is on the one I called practice.
Yeah, no, the draft final.
The first draft, and then there's a second draft there. Stop saying that. Study. Okay, where did I get this one? Was this is the one I called practice. Then the other one was called sample. So basically, the practice is like draft 1 of the final exam. The sample is draft 2. I have probably 4 more drafts to go through before it's suitable for a final exam. It's the way it goes. If you're ever a teacher, you'll know what I mean. All right, so let's see. Highway patrol is flying a plane. So we got an airplane flying through the air parallel to some highway below.
That's a cute little airplane here.
That's pretty good. I've been practicing.
It's actually really good. Compared to-
Using radar, the pilot detects a car whose distance from the plane is 1.5 miles and decreasing. So the car is heading toward the plane. Okay. So the plane is